to this point, you've learned how to convert between moles and molecules, or moles and atoms, moles and formula units. That's using Avogadro's number. And you've also learned how to convert between moles and grams and mass using the molar mass. So, what you now can be able to do is convert between each of these concepts. For example, you could go from mass all the way to particles instead of just stopping at moles. Okay, so just as a review, the relationship between mole and mass, in order to convert between moles and mass, or mass and moles, you need to use the molar mass. Between moles and particles, you use Avogadro's number, the 6.022 times 10 to the 23rd. The last concept that you might be asked to use is the relationship between moles and volume. Well, if you have a gas and it is at standard temperature and pressure, we call that STP. That's a very specific temperature and a very specific pressure, okay? Then the volume of any gas is going to be the same. The volume of 1 mole of gas is going to be the same. It's going to be 22.4 liters, no matter what the identity of the gas is. So now, as you can see, I've got this awesome tool that allows me to relate between all of these different units of measurement. So for example, if I want to go from volume to mass, what I'm going to do is I'm going to go from liters, volume, first to moles, go to the center, using my 22.4. Then I can go from moles into mass by using my molar mass. Or let's say I want to go from mass to particles. I would go from mass to moles using my molar mass, and then I would do another crisscross swish and go from moles to particles using Avogadro's number. So let's look at an example. This question asks me how many atoms are in 30 grams of aluminum. And so what I'm going to be doing is I'm going to be going from grams all the way to atoms. Okay, so I'm first going to put my given, which is 30 grams. Then I'm going to convert. And first, I've got to get into moles, into my center. So I'm going to put grams on bottom, and I'm going to put moles on top. I'm going to do another crisscross swish without waiting, and I'm going to put moles on bottom, and this time I'm going to get into atoms. Now, to go from grams to moles, or moles to grams, I have to use my molar mass. Well, the molar mass of aluminum, I know, so I can plug that in for grams. So for every 1 mole, I have 26.98 grams. For atoms and moles, that relationship is Avogadro's number. So I'm going to put 6.022 times 10 to the 23rd atoms over 1 mole. And so now what I have to do, the last step I have to do is I have to actually figure out the math and figure out how many atoms there are. So I'm going to take 30, I'm going to divide it by 26.98, and then I'm going to multiply by Avogadro's number. And what I get, rounding to 2 significant figures, is 6.7 times 10 to the 23rd atoms. And that's it. So notice for these problems, the only quirky thing is that it might require more than 1 step. It might require 2 steps. But the main thing for you to know is that you are going to first get into moles, because then you can relate anything to moles. Moles are your universal unit, as I like to say. The last new concept that we're going to go over in this lesson is percent mass. Now, if I'm given the values for mass or weight, okay, I can actually just plug them in. So for example, if I were to ask you what percent of my weight is water, if I weigh 120 pounds and 50 pounds of my weight is water, well, that's easy. You would take the mass or your weight of water, which is 50 pounds, and you would divide it by your total weight, which is 120. Multiply it by 100%, and that would give you your percent that is water, which is 42%. Okay? However, what happens if you're not given the mass as you are here? What if instead you're given the formula? So in this problem it says, what is the percent composition of magnesium in magnesium phosphate? Well, first I have to write the formula of magnesium phosphate. Well, magnesium has a 2+ charge, phosphate has a 3- charge. So when I cross my charges, the formula I get for magnesium phosphate is Mg3PO42. All right. What I need to do, just like what I did above, is I need to figure out the mass that magnesium contributes. Well, there are 3 magnesium atoms in that ionic compound, so I'm going to take magnesium's molar mass and I'm going to multiply it by 3, and that's the value that goes on top. So I get 72.9. Then I'm going to divide that by the total molar mass of magnesium phosphate, and I get 262.84. I'm going to multiply that by 100%, and what I get is 27.74% because I want to round to 2 decimal places. And that's it. So for percent mass, I will either give you the masses, and you can do it, or if I give you the formula, you're simply going to use the molar masses of each of the atoms in order to find the percent composition. And that's all there is to it.